quiz to review for Algebra 2. I didn't know how long you're going to be out, so I thought it best to give you this quiz review, and I'll send the quiz on today with it. So for problem 1 of the 12 problems, remember we have on a quiz, the first question is true or false. The point 2, 4 lies on the line 3x minus 4y equals 11. Well, if we plug in 2 for x, we get 3 times 2, and 4 for y, we get minus 4 times 4, which would give us 6 minus 16, which is minus 10, which is definitely not equal to 11, so that would be a false. Now on problem 2, they're asking us to graph 2x plus 4y equals x, and we want to see this in the standard form of ax plus by equals c, so we can read off the x-intercepts and the y-intercepts. Now the x-intercept is always c over a, which for us would be 8 over 2 or 4. That's where it crosses the x-axis. And the y-intercept is always c over b, which is 8 over 4 for us, which would be 2, where it crosses the y-axis. And the slope is always negative a over b, so that would be negative 2 over 4. So when we go to graph, we can see that the y-intercept is up at 0, 2, and the x-intercept is at 4, 0, and the slope from 0, 2 to 4, 0 is really down to right 4, the slope. Okay, now on problem 3, we have a line that's graphed, which has a y-intercept at negative 1 on the y-axis, and to the next point that's shown on the graph, it's up to right 3 to the point 3, 1, and then it goes up to right 3 again to the point 6, 3. So from that we can see that the y-intercept is negative 1, the slope is 2/3 from the graph, and therefore our line is y equals 2/3 x minus 1. Now what we want to do next is get a line that goes through the points 2, 4 and negative 1, 7. So first, whenever we have 2 points, we're going to get a slope from them. So I have them lined up vertically, so I can do y minus y over x minus x. So I have 4 minus 7 over 2 minus negative 3, which gives me negative 3 over 3, or a slope of negative 1 between the 2 points. And then I'll pick the 2, 4 as the point to use for my equation. And with my slope of negative 1, I can plug into y minus y1 equals mx minus x1 as y minus 2 is equal to negative 1 x minus 4. So y minus 2 is equal to negative x plus 4, and adding 2 over, we get negative x plus 6. Now for 5, we want to write the standard form equation, which is a final form of ax plus by equals c, for a line that goes through point 4, 6 and is perpendicular to 2x minus 3y equals 7. Now using our standard form equation again, for 2x minus 3y equals 7, we have ax plus by equals c, and m is negative a over b. So m for this line is negative 2 over negative 3, or 2/3. And since we want the perpendicular slope, that would be upside down and opposite sign, or negative 3/2. Now we'll take our point 4, 6 as our x1, y1, and our perpendicular slope, negative 3/2, and plug that into y minus y1 equals mx minus x1. So we would have y minus 6 equals negative 3/2 x minus 4, but since we want it in the form of ax plus by equals c, we're going to clear out the fraction. So we're going to multiply everything by 2. That's why I see the 2 parentheses y minus 6 and the 2 times above the negative 3/2, which would clear out the 2's there. So I would get 2y minus 12 multiplying through the parentheses equals negative 3 parentheses x minus 4, or 2y minus 12 equals negative 3x plus 12, and then adding 3x on the right side to both sides and adding 12 from the left side to both sides, we'd end up with a standard form equation of 3x plus 2y equals 24. On problem 6, in the triangle with vertices x, which is 2, 7, y, which is 1, 3, and point C, which is negative 7, 5, we want to determine if this triangle is a right triangle. So we're going to take slopes between x and y, which would be y minus y over x minus x, or 7 minus 3 over 2 minus 1, which would be 4. And then a slope between y and z, which would be 3 minus 5 over 1 minus negative 7, which would come out to negative 2 over 8, simplifying negative 1 over 4. And then the two slopes would multiply to 4 times negative 1/4 equals negative 1, which is the test for negative reciprocals or perpendicular lines. So indeed, xy is perpendicular to yz, and triangle xyz is a right triangle. Now for the next two problems, we're going to be looking at the data sets A through D below. So which set of data has the greatest r-squared value closest to a perfect straight line, and that would easily be seen to be A. And which sets of data have a negative r value, which means that a best fit line through the scatter plot would have a negative slope. And whereas B would have an upward positive slope, both C and D would have negative slopes for a best fit line run through the scatter plot. And on 9, we have a trend line of 1.81 minus 3595 with an r-squared of 0.8537, and we would use the trend line above to predict the number of users in 1995. Well, plugging into a calculator, 1.81 times 1995 minus 3595 would give us 15.95 million. And then part B, is this estimate an interpolation or extrapolation? Well, the data given was from 1985 to 1983, and so 1995 was beyond the data or a prediction, which makes it an extrapolation. And since the users, part C, in 1993 are close to 15.95 million, and it was trending upward, 1995 was likely greater than 15.95 million. Question 10 is, if fx is the greatest integer of x over 2, then find f of negative 5, which is the greatest integer of negative 5 over 2, which is the greatest integer of negative 2.5, which means find the greatest integer less than or equal to negative 2.5. Now an integer would have to be a negative whole number here, so we'd have to go back to negative 3 because 0.5 is not an integer. So it has to be less than or equal to that. We couldn't go up to negative 0.2 because that would be greater. So negative 3 would have to be our answer there. And remember to divide your x by 2 first. Now on 11, we have a piecewise or three-part graph which has three parts that we have to graph separately. So the top one is to the left, 3x plus 2. If x is less than negative 1, we can graph that by making a table of x and 3x plus 2. Since it starts at negative 1 and goes left, we can use negative 1, negative 2, and negative 3 for our points. So for negative 1, we have 3 times negative 1 plus 2, which is negative 3 plus 2, or negative 1. So that's the point negative 1, negative 1. For negative 2, we have 3 times negative 2 plus 2, or negative 6 plus 2 is negative 4. And for negative 3, we have 3 times negative 3 plus 2, or negative 9 plus 2, which is negative 7. And shown with the arrow there, we have our 3 points plotted, negative 1, negative 1, negative 2, negative 4, and negative 3, negative 7. Now the middle part of the graph, which is in the middle, is just too high, or a y equals 2 line, which is open at negative 1 and 2, but is just too high from negative 1 to 2 with opens at the end. And then the right side of the graph, negative 1/2 x, starts at 2 and goes to the right. And so since it's got a half in it, we're going to go by 2's. So we're going to graph it and get points at 2, 4, and 6. So negative 1/2 times 2 is negative 1. Negative 1/2 times 4 is negative 2. And negative 1/2 times 6 is negative 3. So shown with the arrow, we're plotting the points 2, negative 1, 4, negative 2, and 6, negative 3 to complete our right side of our three-piece piecewise graph. And for the last question, we want to identify the quadrants for an absolute value equation, absolute value of x plus a plus b. Well, to get quadrant 1, we would be having negative and positive, or a less than 0 and b greater than 0, which would make it right and up. For quadrant 2, we would be positive and positive, or a greater than 0, b greater than 0, which would be left and up. Remember, the right and left are opposite. A right has a negative and a left has a positive for the x part, the inside the absolute value part. For quadrant 3, we would be positive and negative, or a greater than 0, b less than 0, which would be left and down. And for quadrant 4, we would have negative and positive, a less than 0, b less than 0, which would be right and down. Okay, so this finishes the quiz review, and I'll send a quiz along for you, Tom. And I do hope you're feeling better, buddy. Just take care of yourself and do this as soon as you can. I'll be sending a test review here real soon also, because we're almost done with chapter 2.